Hello, I'm Robert Toomey. I'm a cloud research developer at the National Severe Storms Laboratory in Norman, Oklahoma. This is another tutorial in my RAPIO series where I've been working on cross-compiling C++ code. This is meant for developers at the National Severe Storms Lab or outsiders wanting to make a RAPIO algorithm or other MRMS weather algorithm, but the techniques here can be used for your own code and projects where you might want to use a cross-compiling Docker. I'll cover some of the issues I ran into and how I've gotten things working, at least for me. The first part of the tutorial will focus more on the technical details of creating and building the cross-compiled Docker, and the second part will focus more on using it to create a RAPIO or MRMS application. The table of contents below the video should let you skip to your place of interest. So the first, I'll have some quick notes. Like I said, these techniques can be used for creating any cross-compiling Docker. But why do we want to cross-compile? I mean, the number one thing I can think of is that it's freedom from the OS. Patches and changes, basically IT will install an OS for you typically in a production environment where you don't have access to it, right? You're a user, you don't have root. So these things are patched all the time for security reasons. Library versions change, they can change under you, they can break your code basically. Dockers can also be like time friendly. You turn your code into a document. So in theory, if you have a Docker container where you've got your code built, if you tar that up, you should be able to untar that 20 years from now and actually get it to run if you want to. It's kind of like almost like having an emulator. You can also be in control of changes to your container. So if you're a user in a regular IT environment, you don't have root typically to a machine. Now, if you do have root to your machine, that's great. But if you don't, then it's nice to be able to at least have root on your container so that you can, for instance, install a new Python package or an RPM you need for development. And that can be very nice, right? And also, the overhead with containers is actually pretty light compared to, say, virtual machines. I mean, you could create a virtual machine, use like Oracle VirtualBox, do the same type of setup, but you tend to not get quite the speed that you'd get if you do a light container. So with that being said, let's get started. The first thing I'd like to show is just Docker in general. So this isn't about installing Docker, so you have to look up another video or tutorial if you want to install Docker, or you contact your IT people, get them to set that up. So once you've got Docker going and you know some of the basics, you can do Docker images where you see, the images that you've created on a container. And Docker images can stack upon each other. For instance, you can have like a CentOS 8 image, or CentOS 8S, a Fedora 34, and then you stack things on top of it, and you can build on previous containers, which is another thing that's really nice about that. So let's see, where am I? Oh, go to the top folder. Okay, so looking at the top directory here, I've got 4 folders, and the first one is container, and that's basically where I've put all my Docker building scripts and all that. The second one is I've got data in. And since RAPIO deals with weather algorithms, we ingest data into an algorithm and we output data. So you can think of it like a black box algorithm that's ingesting and outputting. So in this case, I prepared a data in set. This is the May 3rd data set for the tornadoes that occurred in Oklahoma at that time. So if we go to data out, you'll notice nothing there. And if I go to this folder called myalgs, there's nothing there too. So this myalg folder, this is the folder I've decided to put on the host where I'm going to build my code into. And the reason why I do that is because containers don't have any intrinsic memory, right? You can exit a container and you can save it. There's commands to do that. But in general, when you run a container then exit, it resets the container, which is it's a dual-edged sword. But the nice thing about resetting is that you don't have to worry about breaking your container so much. If you go in there and make a bunch of changes on your container or you damage the file system or something, typically you can just exit the container, restart the container, and it fixes it. So that's really kind of a nice feature of that. So if we go into the container package, I've got a build container.sh, I've got a run container.sh, and I've got a packages folder. And what I want to do is first I'll show you the build container.sh script. And all I do in here is I basically run Docker build on my doc file, which is in that packages folder. And I pass in some arguments. And what these arguments are is that I give it the user ID that I want to run as and the group that I want to run as. And this is so, like I said, the container, you don't want to run your container as root, because depending on how your Docker is set up, like if you're on the Amazon image here like I am, then if you run your Docker as root, you'll actually write as root, which you don't want to be doing as a developer typically. So in Linux, you do the id-u command, which gives you your actual ID. So let me exit. So I'm running as EC2 user on this machine. So what that'll do is it'll pass that user into the Docker. So now if we go into the packages folder, we'll look at my actual doc file. And this is the Docker file. I've just given it a special name. But you'll notice I pass in the arguments for the ID and the run group. And then I add this user as developer to the container. So what this means is that when I run commands on that Docker container, I'm going to be writing to the host as EC2 user, as my host user, but on the container, I'll be developer. And you'll see why this is very important later on. I also add to the wheel in Linux. This allows me to sudo on the container. This, in a production environment, I'd probably take this out and not let anyone have the ability to sudo to root on the container. That would absolutely guarantee that you couldn't write to the drive as root. I also then copy packages over from, basically I copy things to temp, and then I run an install script. And the reason why I do all this in one step like this is because Dockers tend to remember each step. So if I have to install a bunch of packages or build a bunch of things, then if I just run one script, it does it in one step. It makes the final container a lot smaller. The downside is that it doesn't cache as much. So if you make a mistake, you have to build things more from scratch. So this is the install script that I run. And basically, since I'm building actually on top of Fedora 34, which is the current one at the moment, but you'll notice I got echo command, substep install, extra stock packages. I basically install everything I need for my development environment. So I need it I wanted SVN and Git because we have some SVN repos still. We also have Git repos that we want to check out from. In fact, the RAPIO project's on GitHub right now, so I need Git for that. And then I install a bunch of things here where I do the uncompress. These are all requirements that RAPIO needs. You would put your own requirements in here for what you need. The big things that start off like here, I'm using gcc.cc. So I set up the compiler stuff first, and then I do all the libraries that RAPIO uses. These are also all the RAPIOs that MRMS uses as well. One thing is that almost all of our third-party libraries have development RPMs, which is no reason why I did this. But I had a special requirement of this library here, this g2clib, which does not exist in Linux repos. So I do all the commands here just to build it, install it locally on the machine. Now I'm running this script as root when I build. So I have access to basically build and install on the container. And then down here, I check out my RAPIO project. So this could be your own C++ project that you check out. You could clone it, check it out, and you just make a script to run it. And then I do the make install basically on that project, which will actually put it in user bin, which is what I wanted to do in this particular case. But you could also change your build paths and set it to a local folder on the machine if you wanted. And then I changed the permissions on things to make sure it's the user, because if I make install or I check things out as root, it'll be root. So I changed the permissions finally to developer at the end. So what I want to do now is I'm going to go ahead and build the container, and then I'll pause the video because this will take a little while. But I'll show you the first steps of it. So you see I'm pulling from Fedora 34, and it's showing you the steps, and you're getting intermediary steps for your container as you go. Each one of these, it will kind of cache and go back in time if you make a mistake or it crashes. Except this install that one, since like I said, since I grouped all these yum installs and everything in this, if this one breaks, it'll rerun this one over and over again. I'm going to show this a little bit, but then what I'm going to do is I'm going to pause it because this will take a few minutes to run. Because you saw I had a lot of packages in that Docker. Let me pause that, and when this is done, I'll come back and continue the tutorial. Okay, welcome back. Looks like it built. So now if we do a Docker images, we'll see the RAPIO base and the Fedora, or whatever container you happen to name it to. So when we looked at that build container, right, the important thing was that we had that build arg run ID, basically user. You could hard code this instead of ID-U. You could hard code your group name too. But I used that basically to create the user on the container. Let's look at the run container.sh because we're going to run this. We're going to run this container here in a second. So what this does, okay, first thing I got this source.config.sh, and what I did was I just put everything common in there in case I have to call it. So you'll notice some variables down here like input, output, my alg path. The most important thing here is that, see this user command for the Docker. This is actually telling Docker what user and group to run as when it starts up the script. And then what I do is I run a bin bash because this gives you a shell basically as your top process. This allows you to do your compiling. So, a Docker container only runs a single process, right? So you got process 0. So if you just run any binary, it'll run that process. That's part of its lightweight mechanism. So if you'd actually do compiling on that container, you're going to have to actually have a shell to do it in. So I do basically a bin bash. So I have the alg path, input, output, and basically you'll see what this is here in a second. The host name, the -h gives a host. I call it RAPIO, and then IT gives me interactive terminal and the run command. You can do more. You can read online any Docker tutorial for this to understand more about what's going on there. So I just kind of grouped common variables in this config.sh just to make it convenient for people that are using this for RAPIO to set up. And what I've done is I've just said, okay, my home directory, my algs. So this is where we're going to put algorithms. And then down here we get data in, and this is going to be where we get any data input from. And this is going to be where we get data out. Now, of course, you don't have to use those variables. If you're doing a run container or something, you could modify it basically to do what you want. So what I want to show is I want to show this. There's an algorithm in RAPIO called SimpleAlg, which is one of the example algorithms. And so if you look at this script, got the same thing where I'm reading the input output folders, and I've got run this alg, input, output, my alg, and I got the user. But instead, I've got the binary. I've got my algorithm, the RSimpleAlg, because I know that RSimpleAlg is in the path on the container. So if I run this script, it'll actually run the command as if you were running the binary. So do I want to run that now? Let's go ahead and run that now. So if I run this, let's just do run by itself. Oops, I made a mistake. Let me see. I haven't set up my environment yet properly for the RAPIO algorithm. Basically, what I've done is that the first time you log into the container, it will set up the environment for your building folder. So remember that my algs folder. So basically that my algs on the host gets matched to build my algs on the container. So we have a folder, right, up here, the my algs. It's empty right now, right? So what I'm going to do now is I'm going to go into the container. And what I found is it's good to do it this way. So I'm going to run it this way now. And we've just logged in the container, and you'll notice a couple things. I've got a little banner here, and you can do your own little thing where you make it pretty. But build on Fedora 34. It's GCC version 11.1.1. This is kind of cool because we got the experimental C++ 23 stuff, which is kind of nice if you want to play with it. But you'll notice I get some messages here: setting up template in the build my algs, installing RAPIO config settings into build my algs. The reason why that RSimple was complaining is because this configuration folder didn't exist. If you've used MRMS, you know that we got that W2 config folder. Basically, there's a config folder that has the settings, and we did another tutorial where we showed like some of the RAPIO settings file, which controls things like your netcdf out, your logging levels and colors, for instance. Things like that are all set there. So the algorithm was complaining because it didn't find that. So this is interesting. I'm actually on the container right now, and you'll notice that the username is developer, right? Remember we set that up earlier. But where am I at? Okay, I'm in my build my algs folder, but this folder is actually on the host. So you look at this, it says developer. So I'm going to do a touch test.txt, and then I'm going to exit the container. So now I'm back in my ACT user, right? So let's go up let's look at that myalx folder. Now this one's on the host, right? This is the host folder. So home, EC2 user, myalx. But you'll notice something, right? You've got your stuff in there that was on the container. And you notice the user for that test.txt file I just touched is EC2 user, EC2 user. That's the thing we wanted, right? So if I go back, now the cool thing about this run container, it's in here, but we could move that script anywhere we want because it's just calling Docker. So if Docker's in your path, it's going to work anywhere, right? But the magic behind this is that, remember this input, this alg path was set in that config.sh to be my home user, myalx. But you'll notice here that the script is mapping it on this is the container. So you can do this. I mean, I've done this for input, output, one simple input, one simple output, one simple algorithm path. You can add and do whatever you want. You can add lots and lots of different folders. Say if you have inputs from multiple sources or from some sort of archive that you've got in a set place, you can hard code this in and then do it. The trick is when I run my algorithm, I have to use this name, right? Because remember, ultimately, the algorithm runs on the container. So whatever folder I map to is the folder I actually have to use. So you'll see that in a second. We'll go ahead and run this now. Now we're on the host now. So I have two ways of running algorithms. I could run them by logging into the container and then running it on the container. So if I go in the container like this, right, you'll see like I do which w simple alg. And this is just this is the one that's installed by RAPIO by default. So if I run this, it's actually in my path. But if I do simple alg help, you'll notice I get my help output it, right? And I could run the algorithm here with all its parameters. But I can also run it from the script on the host because I can run it as its own single algorithm. So if I run it here, I get the same thing. So this is where a lot of the power of the cross compiling comes in play. So what I'm going to do now is I'm going to run this and I'm going to input, and I want to run from, I got to do input because that's the container folder, right? Even though I got data in one folder up, I want to run it from this. So I'm going to do this, and I think it's KTLX, and I have a code index. This is just our data input. And then my output, I'm going to set it equal to output. And that's just normal output. And then I'm going to do N, and this is something you don't do in MRMS, but I'm going to do it in RAPIO. I'm disabling notifiers. I don't want to write FAM files. It's like, there's no point to writing notification in this case. So if I run that, you'll see it going like crazy here. And the rsimple just does the mirroring. We've looked at that in previous tutorials. And it takes it a couple seconds. I'm not going to borrow the pause here because it's too quick. But you'll notice if I go up now, I look at my data out, you'll see my output data, right? So this is all I did was echo. So I echoed netcdf data. That's what that particular algorithm does. But you'll notice that, also in this case, the user permissions are EC2 user. But that algorithm was ran on the container. It wasn't ran on the host. So this could have been a Windows machine, Mac OS. It happens to be EC2, Amazon Linux. But if I do a G++ version on here, I forget what version I got. It's version 7.3. Still not too old, at least at the time of this video, but it's not G++ 11, right? So that algorithm was actually compiled with G++ 11. So let's look at the next thing we really want to look at. And this should be, I guess, considered part 2, is that we want to actually build a new algorithm on the container. So that was the rsimple algorithm was the stock one. So what I'm going to do, I'm in build. I do an ls. Knows two things. There's a RAPIO folder. This is just the build of RAPIO that's been installed in the container for you. There's a third-party folder. Normally on an MRMS build, you've got all the packages, right? GDAO and all that. Well, Fedora 34 is so modern, it has all those packages. So the only thing I've got in here is G2CLib, which is what's not available on the stock Fedora. And then I've got the myalx folder, which when I first logged in, it filled in a few things. First, it put the RAPIO config folder in there, which is the permissions and settings for running algorithm, or the settings, color maps, everything for RAPIO. It also made this template folder, And what this template folder is, this is just it's an algorithm, basically. It's a template of an algorithm. So what I've done is I've made a script here that if you want to make a new algorithm, just say make algdir. Let's make an algorithm called storm motion, because I'm thinking about doing a tutorial where I make an algorithm that actually does that. So when I do that, it makes a folder called storm motion. So I go into storm motion. There I am. There it is. I've made a runme.sh that basically what it does is I put in a thing where I've put in a stock input output where it runs the input output on the thing. So this by default is an algorithm. I've made an algorithm called storm motion. It's got the basic option declaration, process options. There's a bunch of comments in it basically to kind of help you get started. So all this algorithm does is read in a data type right here. Let's see. I've got the RAPIO command for reading in a data type. I read in any data type, and if it's not null, then all I do is write it with the same type name out. Boom. So that's what's doing that mirror. That's basically a RAPIO mirror operation. So I've got a make file generated. Now, if you want to use auto tools, you want to use CLang, you want to use a different compiler, you can do that, whatever you want with setting this up. But basically all I've done here is I've actually done a static makefile. And the reason why I can kind of get away with this on this system is because, well, since I've picked Fedora 34 and I know everything that's installed in the system, I know what the container's got on it, all I got to do is just basically do a simple make. So here I put the name of the algorithm and I put the C sources and I've got some GC++ compiler flags. You could use, ccons or whatever, cmake or anything else, but let's just make it. So I do a make and you'll see it's very simple. I've only got one C++, CC file in this case. So we now have an rstorm motion. So when I run that, there you go. You got an algorithm. So there's a new algorithm. Now we could run it on the container here. We could actually run and do our input output. So if I wanted to do storm motion and run it natively on the container, I could do the same thing. Kind of wishing away that I had macroed this or something, but we'll just be patient here. So if I run, I did that run me script. So I have the run me script. So you see it's doing the parameter input output. So I'm going to go ahead and do the run me. And that'll do the same thing. But you see, it's not really looking like it's any slower than when I ran it on the host, right? This is running on the container, versus running on the host. So I think we got, 10 seconds it took it to run it on there. Now if I exit the container, I can go back and run. I could run the simple alg again. Let's see. It took 6 seconds but anyway, you could make your own script here, where now if I took this run me algorithm and I changed this to, what was that thing called? Storm motion. So let's do that just for fun. Let's change this. So our storm, I think it was storm motion. And then let me move it. Let's go with storm motion. Now if I run that storm motion, and I goofed up the binary, it looks like. But I'm just playing around a little bit just to kind of show you what's going on. So we go back in the container. Right, we got storm motion. What did I call that binary? Call it rstorm motion. Not in the path. I know what the problem is. Okay, so it's not in the path because it's not made installed. So okay, so what we got to do in this case is that I need to do a build. I need to actually tell it the path on the container. So we'll do a build myalgs, and I think it was called storm motion. And let me see if that's right. And there we go. See? So the reason why is because RAPIO is installed on the container, so it's actually in user bin. And the path, since we added a new algorithm, it's not in the path on the container. So if you see that error, then you'll know that it's not in the path. Remember, the path's got to be the one that's actually on the container, not on the host. But you'll notice, like for instance, I could then take that script that I wrote, right? I can put it here. So now I'm on my host. I've got my container, my data in, my data out, and I can run my algorithm all day long. I can just do whatever I need to do where I run my algorithm. Okay, so I broke things again, but it looks like, okay, so why did that break in this case? Because I have this config.sh script that I have in there. So, you know, if you're going to do one script and move it around, you might want to just put the hard code the flags in there. I may be trying to be too smart for my own good on this. So if we look at this should run now because the config.ace is in that directory. Yes. Okay. So there it goes. So like I said, I may be too smart for my own good here. You could, if you're going to do a lot of stuff and move the scripts around a lot and you want them to work anywhere, you might just hard code your folders and your alg path and stuff and not use variables and try to be smart. I'm just trying to do this at someone who just uses the container folder to start will have at least something that works and works with minimal amount of effort. So we'll get rid of that. I'll get rid of the store motion, but you'll notice that, you know, I can run it from the container or from the host, which was the main point that I wanted to show. Okay, so I want to show a few more things real quick and just some common gotchas that you can have. So if we look at the myalgs, I'm now on the host, right? So I've got that store motion folder. That is my algorithm. So what happens if I go into here and try to run this directly? What's going to happen? I'm going to get an error, right? Because I'm trying to run an algorithm on the host machine OS that was built on the container. If I do an LED in this case, you'll notice I'm actually surprised how many libraries were found. It looks like, I mean, the Amazon Linux is not too far off. The RAPIO is not found, but you've got other libraries. But typically, if you're linking to the libraries on the container OS, they'll be much more modern, say, than your host. It can be modern or not, but you don't want to try to. Usually, your binary is not going to run on your host. Now, they're really, really close. Host and container, they're close to each other. It might actually run. So if you have that option, that's cool. But if, for instance, if this is a Windows host, there's no way it would actually run, right? So that's one thing to keep in mind. Another thing I like to show is that we showed that make algdir doc directory, and basically that make algdir is what you can use to make a new algorithm. So when I ran that store motion, for instance, I did make algdir, and then I do my new alg, and it basically makes that and sets it up for you. So you can see how quick it is to make a new alg. I just run make. Oh, did work because what mistake did I make? I tried to build on the host, right? So it is a little tricky for people new to Docker and new to cross compiling to keep track of. You got to make sure that, when you're building, you want to be on the container, not on the host. And I still catch myself making that mistake. So when I see this error like this, why is this happening? It's because there is no RAPIO.h. These libraries don't exist on the host, right? I'm trying to actually build, and I'm trying to do a compile with, GCC 7.3 when I've got a folder and set up for GCC 11. So that's one of the areas you might see. You see that error, you'll know, oops, wait a second, EC2 user, I'm on the host, I'm not on my container. Now, the other thing I have this make docs.sh, and this is a doxygen script. Now, of course, if I run this, I think it's going to just flip out because, I actually put in the script, run this logged into the container. Okay. So what I'm going to do is I'm going to go back, and I'm going to run my container and get into my container. Now I'm going to go into my aux here. If I can type. Third time's the charm, right? My aux. And I've got the make docs here. Now when I run it here, what's going to happen? What I've done is I actually have, I think a doxygen set up on here. So when I do the make docs, what it'll do is it'll just go ahead and spawn a doxygen in dot graph. And I could let that run and think about something else to talk about. But basically this way, what doxygen is if you don't know what it is, it generates HTML, PDFs. It takes the source code and it will generate a a documentation system for you for that code. So you can basically document code inside your code. And it can be very useful. So what I've done is I actually have that on the template as well. And you'll notice this HTML folder here, and you've got a bunch of files, but the main one that's important is like index.html. That's your starting point for the documentation. And if you're on a host machine, once you do that, you wouldn't want to do it here. You'd actually want to go to your host, but then on your host, whatever web browser you happen to have, let's say like in Linux, if you've got Firefox or a Chrome, I forget which one. This is Amazon Linux. So I don't even know if they've got one on here or not. It may be Chrome. I don't know what web browser is on here, but whatever web browser that you have on your host, you basically can now do, you can go in HTML and you can do like Firefox index.html, whatever. And you can bring up a window on your host that shows you the documentation and that's the documentation for RAPIO. Let's see. And one last thing I'd like to show is we're going to go back to the container again. Is that with this particular container, remember I showed you that wheel command in the build. So what that does, it allows me to, I believe it's just this. Can I do sudo? Yeah, I can sudo to root. So let's say I wanted to install something like, Python 3 or something. Basically, I can sudo and I can go ahead and do my standard Linux install stuff. I'm not even sure I'm going to let this run all the way or not, but because it looks like my mirror is a little slow here. It's not actually the container that's slow. It's the network connection to this particular mirror Fedora having issues, it looks like. I'm going to go ahead and cancel it if I can. All right, maybe not. We'll let it run. But the idea is that with the sudo, you can basically install something that you need on the container. Now, the thing you got to remember, there's two ways to mess with the container. You can hit Control PQ, right? And I think of it as the top right letter on the keyboard, on the QWERTY keyboard, and the top left letter on the QWERTY keyboard. So if I hit Control PQ, it'll basically detach me from a Docker container. So that container is still running. So then when I do Docker PS, you'll notice you actually have a Docker, right? And you can Docker attach. So you can either do it by the container ID, or you can do it by the fancy name. I'll do it by the container ID here right now. But see, I'm back in the container. So you can either do it that way and reattach. But when you exit, right, you're going to lose that container. So if you installed a bunch of packages on it, it's not going to keep it. So you have to keep that in mind. Usually what you do is you're either going to do a Docker save, you're going to save that container as a new container, or you can actually make your own Docker file and build a Docker where you use the Docker why do I know? Oh, I'm in the container still. I actually don't have Docker on the container. It's on the host. So you can actually use RAPIO, for instance, as the base, because this RAPIO F34 was building on top of Fedora 34. So you can chain containers as far as you want. So if I wanted to, for instance, try to build the MRMS Woodsy build, I could actually build it on top of this, and then I could save the container, which is something I probably will try to do in the future. So I think we've shown the basics of how to create a container, a cross-compiling container, and how to build, and maybe some of the issues that you'll see if you get your container and host flipped up. Like I said, I'll restate it again. The biggest thing that can be confusing is getting confused if you're on the host or on the container and what you're able to do on either one. That's probably the biggest thing that I see, that I run into personally, and I think that other people probably would run into personally too. Now, the container doesn't really matter that much. Now, with this myalgs, basically what you can do is you can tar this up, you can date it, you've now got it, you can go back now, when you get a new container, you can go back and recompile it and build it, or you can use your older container and rebuild it, and you'll be guaranteed to get the build that matches whatever that particular container is. And that, I think, is like one of the most powerful, awesome things you can possibly have with cross-compiling with containers versus hosts. So with that, I think I'll end this tutorial. And basically, GitHub, where you're going to get it, there's RAPIO. I'm probably going to have the container folder as a subfolder in the RAPIO build. There's also the RAPIO builder, which does the full super build for MRMS, where it builds every container or every package and links it all together. But that's kind of monstrous. I'm trying to move away from that with the cross compiling. The one thing I want to mention, this is current, but not in the future. This probably isn't going to be an issue, but when you clone now, you're going to have to start using basically the GitHub, because what's happening is that Git is moving with public-private keys, where you have to actually put your public key or public key on the GitHub to where you can check it. It's moving to a system kind of like the Amazon PM keys for logging into machines. It's just an extra level of security and protection. But most of the world, I think, GitLab, GitHub, and a lot are all moving to this. I think in July 2020, around that time. And like I said, most likely the cross-compiler container will be just maintaining RAPIO, not the RAPIO builder. That's because, this little folder that I showed you is extremely tiny. So I'm hoping to keep that folder as a current, up-to-date build container for doing cross-development. But with that, I'd like to thank you for watching, and I hope that helped a little bit in your understanding of containers and hosts.